In this example, we will learn about distributions. For a normal distribution, to find the probability, we will write is equal to norm. Select normal distribution. So x we want to find for A8, which is 42,000, comma mean is 40,000, comma the standard deviation, which is 10,000, comma true is what we want. So we will select true, close the brackets, click enter. So the probability is 0.58. Now using the standardized function will give us a z value. So we write is equal to standardize. So we select the x, which is A8, the mean, comma the standard deviation, close the brackets, click enter. So this is what we get is a z value. To make this into probability, we will use the norm S dot distribution, where we will select the z value, comma true, close the brackets, click enter. So we get the probability, which is the same as that we did by finding the normal distribution function. Now to find between two values, we will first find for the specific value. So we will find for 35,000. So we will do is equal to norm dot distribution. So 35,000, comma the mean, comma standard deviation, comma true, close the brackets, click enter. And similarly we will find for 49,000 is equal to 49,000, comma mean, comma standard deviation, comma true. So to find in between, we will write is equal to C12, which is 0.82 minus 0.31, which gives us 51. Now to check if this is correct, we will use the formula is equal to norm distribution. So for 49,000, comma mean, comma standard deviation, comma true, close the brackets, minus norm distribution again for 35,000, comma the mean, comma standard deviation, comma true, close the brackets, click enter. So you get the same probability, which is 51%. Now for a uniform distribution, we have the A value, we've named it as A val, B value. So to find the PDF, we write is equal to 1 over B value minus the A value. We don't have a specific formula or function that we can use for uniform distribution, so we need to use this formula. Now for CDF, we write is equal to brackets x value minus the A value, close brackets, into the PDF value, and click enter. So you get the CDF value. Now for the Poisson distribution, you write is equal to, select this Poisson distribution. So x would be 35 here, which is the number of customers, comma for mean you would have 20 customers per hour into the number of hours. So that would be 20 into 2, comma your value would be true, close the brackets, click enter. So you get the value as probability as 24%. Now for the exponential distribution, to find the inter-arrival rate, which is the hour per customer. So you know here that 20 customers per hour is what we have. So here the interarrival rate would be the inverse of 20, so that would be is equal to 1 over 20, which gives us 0.05. Now to find the interarrival time, now suppose you say a customer arrives in 10 minutes, so that would be is equal to 10 over 60, which gives you 0.17. Now to find the exponential distribution, you would write is equal to exponential distribution. You will write x, which is 0.17, comma lambda, which is 1 over the interarrival rate, comma it is true, close the brackets, click enter. So you get it as 96%. Now we will learn about binomial distribution. So binomial distribution is related to the successes and the fails. So we will write is equal to binomial distribution. So the number that we want is for 50, comma the trials is 100, comma the probability of success that the viewers will be watching television is 60%, so we will select this, comma it is true, close the brackets, click in. Now for the beta distribution, we will first find the transform mean. The formula is mean minus lower upon the lower minus mean. So you have mean minus the lower, close the brackets, upon the upper minus the lower, enter. Standard deviation we will write is equal to standard deviation raised to 2 over the upper minus the lower raised to 2, click enter. To find the alpha, we will use this formula here, which is the transform mean into 1 minus the transform mean over the transformed standard deviation, close the brackets, minus 1, close the brackets, click enter. And for beta, we will use this formula is equal to 1 minus the transform mean into transform mean into 1 minus the transform mean over the transform standard deviation, minus 1, close the brackets, click enter. So now to find the beta distribution, you write is equal to beta, not distribution. Your x is the project time, comma your alpha is 0.08, comma your beta is 0.03, comma 7, comma your b is 14, close the brackets, click enter. So you get the value of 0.28. Now to find the Weibull distribution, we write is equal to Weibull dot distribution. We write x, which is 1320, comma the alpha is 14.71, comma beta is 1243.44, comma true, close the brackets, click enter. So you get 91%.